And good evening, class. Welcome to a flipped classroom. And so hopefully you're all comfy and in a good location, ready to watch this video. On a more serious note, don't forget you do want to take notes. And because it is a video, you have the capability of pausing or rewinding, whatever will help you to better understand the material. All right, so let's go ahead and get into this lesson. This is Algebra 2, Lesson 1.3. You always want to make sure that you are on the correct lesson. This is lesson 1.3, and I'm going to do all of my Algebra 2 lessons with the green title page. All right, so Algebra 2 will always have a green title page, and the lesson today is Products of Polynomials and an Introduction to Matrices. Products of Polynomials and an introduction to matrices. All right, let's jump into it. Again, remember, this is all review, and so I'm going to go quite quickly. Forgive me for that. I know it's been over a year since you've had your Algebra 1, but I do know that we've learned these concepts and we've learned them well, and so I'm going to go quite quickly. So lesson 1.3, products of polynomials. Products of polynomials. Whenever you think of polynomials and you think of products, of course, you're thinking multiplication. When you think of multiplying polynomials, there should be one word that should come to your mind. Now, I'm going to write that one word in red here, and that word is distribute. Distribute. And so you got to remember to distribute. If you can distribute, you can take care of multiplying polynomials. All right. We first need to do some exponent rule review. So number one, exponent rule review. Exponent rule review. All right, the first rule should be very familiar to you. It's x to the a times x to the b, and that's going to equal, do you remember? X to the a plus b. I'm going to write that plus sign in red. X to the a plus b. So you're multiplying the same variable, perhaps the same exponent or different exponents. How do you do that? You add the exponents. Simply, the rule is simply a shortcut. So an example would be something like this. N to the fifth times n to the negative first. What do you want to do? You simply want to add the exponents of 5 plus a negative 1, and we all know that that gives us a solution of n to the fourth power. Right? N to the fourth power. What about if you have coefficients? That's possible. So let's suppose we have something like this. How about 2x squared times 5x to the fifth? All right, well, remember, with multiplying, you're going to multiply coefficient times coefficient. We can do that. 2 times 5 is 10. But now you're going to apply the rule we have written there to the variables. X squared times x to the fifth is x to the 2 plus 5, or x to the seventh, right? So you get a 10x to the seventh, a 10x to the seventh. Okay, well, what else? B. Do you remember this rule? An exponent to an exponent? X to the a to the b power. And if you remember, that ends up being x to the a times b. X to the a times b. I'm going to box that in green. So you end up multiplying exponents. Okay, in its most simplistic form, it's something like this. N cubed to the, I don't know, 9th power. And so all you're simply going to do is multiply the 3 times 9 and get n to the 27th. Right, n to the 27th. Now if you take this rule and expand it, it'll look a little bit differently. So I know it gets to be a lot of letters here, but hang in. Let's have a parentheses. Let's go x, y to the z, parentheses, and all of that, I don't know, let's take that to the a power. In this kind of situation, you have to distribute this a here to the x's exponent and here to the y's exponent. So if you were going to do this rule, you would end up with x to the technically 1 times a, and then y to the z times a. Now we need to clean that up or simplify it. So you end up with x to the a, y to the az. You would always put your variables in alphabetical order. So x to the a, y to the az. X to the a and y to the az. Right, be careful with coefficients here. Let me give you an example of this. Suppose we had something like this. Let's go with parentheses 2a squared b quantity cubed. Okay, so remember we have to distribute this 3 times each exponent. So we're going to end up with 2 to the 1 times 3, or 2 cubed. A to the 2 times 3, or a to the 6th, and b to the 1 times 3, or b cubed. Now, by the way, again, if I'm going too fast for you, use the pause button or you rewind. But again, this is all review. Just a reminder here, remember we don't leave numbers to an exponent. We need to simplify that. 2 cubed is 8, right? 2 times 2 is 4 times 2 is 8. And you still have the a to the 6th, b cubed. So 8, a to the 6th, b cubed. All right, one more exponent rule, D. How about something to the 0 power? Something to a base to the 0 power. Now, a lot of you know that the answer is 1, but do you remember why the answer is 1? All right, the reason, and again, in Algebra 1, we took some time and I developed this fully. We don't have the time to do that. This is all review. But remember, a 0 exponent means the base divided by itself. And whenever you divide the base by itself, you end up with 1. So any base to the 0 power is 1. So, a couple reminders. How about a problem like this? What would 3n to the 0 power be? Well, be careful here. As I've tried to teach you, the exponent only goes to its base. It's only the n that's to the 0 power. So this is 3 times an n to the 0 power, or 3 times a 1. The final answer is 3. Now that would be different than this. Parentheses 3n, close the parentheses to the 0 power. Do you see the difference? Remember, in this case, the base is everything directly below and to the left, and the parentheses says it's everything in that parentheses. So just to technically show you what you would have the base 3n divided by itself 3n, and anything divided by itself is 1. Right? So the answer to that would be 1. 0 exponents. Okay, that's exponent rule review. Let's continue. Number 2, multiplying monomials. Multiplying monomials, and I'm just going to go monos, I guess. Multiplying monos. Okay, multiplying a monomial times a monomial. Okay, so in its simplistic form, it would be something like this, right? Let's go 2x times 3x squared. So how are we going to multiply a monomial times a monomial? Well, we're going to do coefficient times coefficient. The 2 is the coefficient of the x, and the 3 is the coefficient of the x squared. 2 times 3 is 6. Easy enough. Now, when we get to our variables, we're going to apply the exponent rules. What's an x times an x squared? That's x to the 1 plus 2, or x cubed, right? And that's the solution, 6x cubed. What about something a little bit more challenging? So again, this is review. How about something like this. How about negative 2 x squared y, negative 2 x squared y. Let's go parentheses or times 5y squared, close the parentheses. And let's go another parentheses times negative x cubed y squared z. All right, so we're multiplying three things. So how would you multiply three numbers? Well, you multiply the first number times the second, and whatever you get, you'd multiply times the third. That's exactly what you're going to do here, to multiply all three together. But in this situation, we're going to do coefficient times coefficient. Okay, negative 2 times the 5. It's easy. Negative 10. Now be careful here, because it's not shown, but this is really a negative 1 x cubed y squared z. So we now have a negative 10 because of the negative 2 times 5. Negative 10 times a negative 1 is a positive 10. Okay, numbers are done. Let's get to our variables. I've got an x squared here. No x's in the second term. I go to the x's in the third term. X squared times x cubed is x to the 2 plus 3, or x to the 5th. Those are done. I'm looking for other variables. Here's a y. Y times y squared is y cubed. Y cubed times y squared is y to the 5th. And then I also have this z just hanging out right there, and it's got to be included. And so you get 10 x to the 5th, y to the 5th z, and you have multiplied monomials. All right, number 3. Let's get to multiplying polynomials. Multiplying, I'm going to abbreviate, polys. Multiplying polynomials. All right, as we said at the introduction to this lesson, remember, multiplying polynomials is all about distributing. It's all about distributing. And you've got a couple situations. The first situation is when you're multiplying a monomial times a poly. Mono times a poly. And we're just simply going to distribute. We're going to distribute. How is something like this? Negative 2x times the quantity, so that's our monomial, negative 2x, times the quantity, 3x minus 7. All right, and that's our polynomial, in this case a binomial. Well, what do? You want to distribute the negative 2x to all terms of the polynomial. Now, as I taught you guys, always include the sign with it. This is a negative 2x, and that's what we're going to distribute. So a negative 2x times a positive 3x. Negative 2 times positive 3, negative 6. X times x, x to the 1 plus 1, or x squared. Okay, now let's distribute the negative 2x times the negative 7. Negative 2 times the negative 7 is a positive 14, and then times the x of the front term, and that's the solution. Negative 2x squared plus 14x. All right, let's get to B, a binomial times a binomial. All right, a lot of you, when you see a binomial times a binomial, you may be thinking of the word FOIL. And FOIL stands for first, outer, inner, last. And as those of you that have me for Algebra 1 know, I don't bother teaching the FOIL method. I don't teach you how to multiply binomials together by the FOIL method, because you need to learn how to distribute. And if you can distribute in a binomial times a binomial, then you can multiply any polynomials together. You can multiply a binomial times a trinomial. You can multiply a trinomial times a trinomial. You can multiply a polynomial with 8 terms times a polynomial with 15 terms, because you have the concept of distributing. And a binomial times a binomial is the base model of learning that distributing. And so let's just simply distribute. Let's simply distribute. Okay, so to refresh your memory, we're going to do something like this. All right, let's make our first binomial, we'll go simplistic, x minus 3. All right, so we have an x minus 3, and we'll make the back binomial a 2x plus 5. So we have a monomial times a monomial. All right, simple. Start with your first polynomial with the first term, and that's the x. And distribute or multiply times all terms in the back polynomial. So the first multiplication would be the x times the 2x. And x times a 2x is a 2x squared. Because there's a 1 understood, 1 times 2 is 2. X to the first times x to the first is x to the 1 plus 1, or x squared, right? We're multiplying. All right, now let's distribute the x to the back term. A 1x times a 5, 1 times 5 is 5, and then it's times the x. And so you end up with 5x. Okay, we distributed the front term of the front polynomial. Let's distribute the back term of that front binomial. Negative 3 times a positive 2x. Negative 2 times 3 is a negative 6 times x is a negative 6x. And if you remember, I taught you guys how to line up your like terms. Notice both of those are x to the first power. All right, let's do the second distribution. Negative 3 times a positive 5 is a negative 15. We want to add like terms to finish up our multiplication. 5 positives of them and 6 negatives of them leaves you 1 negative of them, right? And so you get 2x squared minus x minus 15. Now, one reminder, be careful, be careful, be careful. Here, I'll use my stars. Oh, didn't get the right one. There we go. All right, be careful of this situation. Let's suppose you had something like the quantity 3y minus 1 quantity squared. The common mistake is to think of this as 3y squared negative 1 squared. The reason that's wrong is when we did the rule earlier, it was a monomial. The rule works for monomials. It does not work for anything else. This is a binomial. And so you have to do what does squared mean? It means the base times itself, right? So we've got a 3y, the base, times itself. 3y minus 1 times itself, a 3y minus 1. How would you finish this off? Distribute, right? Distribute, right? And add like terms, and voila, you'd multiply your binomial times your binomial. All right, let's do one more. C, and that's a poly times a poly. Makes you want a cracker, doesn't it? All right, poly times a poly. And so, how about something like this? How about a 3y minus 2z? It's in parentheses, it's a binomial. And we'll multiply it times a trinomial. So parentheses, let's go 3y squared plus 4yz. And we'll go minus z squared. So if you remember, all you're thinking about is distribute. All right, so if you want to work the problem and see how it turns out, go ahead and pause the video. Otherwise, I'm just going to continue on. So if you want to work it yourself, pause it, go ahead and solve it and see if you got it right. All right, here we go. So I've got to distribute first times first. A 3y times a 3y squared is a 3y cubed. First times second, 3 times 4 is 12. Y times y is y squared times z. Distribute my front times my back. 3 times a negative 1, understood, right, is a negative 3. And then you have the y and the z squared. Okay, let's distribute my back term again. Don't forget the negative. Negative 2z times a positive 3y squared. Okay, negative 2 times positive 3, negative 6. No problem there, right? Now, we're going to have a z and a y squared. We should put our variables in alphabetical order, so we'll put the y squared first and the z. And notice those are like terms, and that's why I lined them up. So we're going to end up by adding like terms. Okay, let's go to the next one. Negative 2 times 4 is a negative 8, and then you get y, and then z times z is z squared. And again, you see like terms, right? And we'll finish off with the last. Negative 2 times a negative 1, negative times a negative is a positive. Z times z squared is z cubed. We'll finish this off by adding like terms, 3y cubed. 12 positives, 6 negatives leaves you 6 positives. Of them, what are they? Y squared z's. 3 negatives of them and 8 more negatives of them is 11 negatives of them, right? So negative 11yz squared plus 2z cubed, and you get 3y squared plus 3y cubed plus 6y squared z minus 11yz squared plus 2z cubed. And that's our multiplying of our products of polynomials. Okay, let's finish up then with our matrices, and this will go quite a bit quicker here. So chapter 1 matrices, M-A-T-R-I-C-E-S, chapter 1 matrices. All right, matrices is plural, and the singular is matrix. So what is a matrix? A matrix. A matrix is simply this. It's defined as a rectangular array of data. A rectangular, in other words, it's a rectangle. A rectangular array, don't let that word scare you, of data. It's just data arranged in a rectangle. That's what it is. Okay, so for example, usually we will use capital letters to classify or to label a matrix. So I'm going to use here capital B. So this is going to be matrix B. So I'll use an equal sign, and you have brackets on both sides of matrices. So I have a bracket, and I'm going to put a top left, I'm going to put a 3, and to the right of it, I'm going to put a 1, and to the right of that, I'm going to put a 4. And then below the 3, I'm going to put a 7. Below the 1, I'm going to put a -2. And below the 4, I'm going to put a 5, and I'm going to close off the bracket. Okay, so we have a matrix. We have a rectangular arrangement of data. That is a matrix. All right, some terminology. So, letter A, each piece of data is called, each piece of data is called, each piece of data is called, and I'm going to go to red here, element. Element, you guys had elements in geometry, right? Members of sets were elements, okay? Or we could call them an entry. So they're called either an entry or an element. I've seen it both ways. B. All right, again, you should put an asterisk here. All right, I'm going smiley face. Okay, so this is something that's important. Make sure you remember this. Matrices are described by their matrices are described by their matrices are described by their, I'm going to go to red, dimensions. Dimensions. Matrices are described by their dimensions. All right, if you've done any work with spreadsheets or databases, you've worked with rows and columns. Rows and columns. And those are the dimensions of a matrix. I'm going to come underneath here and use parentheses, and in red I'm going to write the word rows. I'm going to use a blue X, meaning multiplication. All right, look, algebra, we usually don't use an X for multiplication, but in matrices you do. And then I'm going to go with green, columns. So what are the dimensions of a matrix? The rows times the columns. So look back at our example here of matrix B. I'm going to use some color here. I'm going to circle the 3, 1, 4. That is row 1, right? And then I'm going to circle in red the 7, -2, 5, and that is row 2, right? So we have 2 rows. So matrix B is a 2. I'm going to use my blue for my times, get my green out. And you can see the 3 and the 7 form column 1. The 2 and the -2 is column 2. The 4 and the 5 is column 3. So this is a 2 by 3. A 2 by 3. Matrices are described by their rows times their columns. What if you had, for example, something like this? Matrix T equals bracket. Let's go 0, -1, -3, 5, bracket. Right, this is a unique matrix. It's called a row matrix because it consists of just one row. And what would be the dimensions of this matrix? What would be the dimensions? Well, you would say, hey, there is one row and there are 4 columns. So this is a 1 by 4, right? A 1 by 4. Okay, one last thought and we're done. C. Each element can be located by a subscript. Each element can be located by, let's say, its subscript. Say I don't see any subscripts. All right, not in the matrix itself. And here's what I mean. This is just a classification system. It's just an identification system. So let's go back to the example up above of matrix B. If I want to talk about any single element, I'm going to use the lowercase b. All right, lowercase b means an element of matrix B. And what I can do is I can use a subscript to identify which of the 6 elements I'm talking about. I'm using my red here, and I'm going to, like Michael Jordan, so I'm going to go for Jordan's number, and I'm going to go in red a 2, and I'm going to take my green, and in green I'm going to go 3. So B sub 23. All right, do you have any idea which of the 6 elements is B sub 23? What would you guess? B sub 23. Well, hopefully you thought this, and the color should have helped you. I want the element that's in row 2, column 3. What element is in row 2, column 3? It is the 5. All right, you got the idea? So what if I asked you for B sub 12? What would you say the solution is? B sub 12. Well, hopefully you said, hey, row 1, column 2, and therefore row 1, column 2 is the 1. All right, that's it. The first lesson of flipping the classroom is complete. And what we'll do is tomorrow when you come into class, you will work problems over these aspects, and I'll be there to help you out. All right, hope you have a great night. I hope you're looking forward to school in the morning.